My name is Makayla Waller, and I'm going to talk about drug-resistant Mycobacterium tuberculosis. Mycobacterium tuberculosis is a gram-negative aerobic bacteria, and it makes sense that it's aerobic because it infects in the alveoli of the lungs, and it can spread from there if it's not treated, but it's also capable of fermentation if there is no oxygen available to it. For treatment, the most common are streptomycin, isoniazid, and rifampin. Rifampin, it's bactericidal. It inhibits the mRNA elongation, and the strains that are resistant to rifampin typically have mutations within the structural region of the RNA polymerase, and that is at the rifampin resistant determining region. And isoniazid, it only really kills the active strains of TB, so a lot of the time the treatments are minimum of 3 drugs at a time to help combat any kind of overlaps and mutations in the TB. And because the isoniazid only goes for the active strains of TB, the inactive or latent infections may not get treated, so they have to combine it with something like rifampin or streptomycin, or maybe both. So TB drug resistance, they knew that it was going to be an issue back in the 1950s whenever isoniazid became like the most popular and used drug to treat TB, but they didn't really test for the drug resistance, even though they should have been testing for it. And so they would just issue the drugs, the first round of drugs like isoniazid, and then they would see if it would cure the infection, and if it didn't, then they would do the testing, which they should have done the testing in the initial diagnosis of TB. TB can be resistant to just one drug or multiple drugs. There is isoniazid resistant TB, there's rifampin resistant, and then there are multiple drug resistant TB, which have to be resistant to at least isoniazid and rifampin to be considered multi-drug resistant. And then there's also a form of TB that is becoming resistant to all of the drugs that we currently have to treat TB, and those are totally drug resistant. There are certain genes that influence the susceptibility to TB treatment drugs, and like those genes could be the genes that code for the drug targets or the drug activating enzymes, which are including SNPs, insertions, deletions, stuff like that, and also chromosomal mutations, which they alter the drug target or they disrupt the drug target alteration, or they overexpress the drug target. It just kind of depends. And there are some genes that are, or strains, that are more likely to spread the resistance genes than other strains. And then in different regions of the world, there are different strains of TB that are more or less resistant than genes found in other regions of the world. So like, for example, there are mutations within the CATG S315T gene and the inhibitor A promoter region, and the CATG, it codes for a high level resistance to isoniazid, and the mutation within that gene leads to an upregulation in the inhibitor A promoter region, which is actually a factor of the fatty acid elongation system, which is required for mycolic acid synthesis. So the upregulation of this helps the bacteria to become more resistant to the drugs because it affects the targets of the drugs. And it seems that the CAT-G mutation seems to be more common in the European American strains of TB, and then just mutations within the inhibitor A promoter region seem to be more common in kind of near the Indian Ocean regions within that zone. And mutations that cause resistance, scientists have been studying these, and hopefully through the study of these mutations, we can figure out exactly what is causing the resistance to all these drugs and see how we can better fight this issue. All right, and that is all. Thank you.